Welcome back to Breaking Down Storage Tech. Today we are breaking down a quad bulk storage by Pyra. Now the top display was done by Walter and the bottom display was done by Mooney Inspired, but the whole thing was put together by Pyra Left. And it is a fully hopper locked system with 4 bulk silos per slice, and the top 2 silos have a capacity of 1.564 million items, and the bottom ones have 1.594 million items. So let's just get straight into this system. So, what is a bulk storage? We can start there. A bulk storage is something or a storage that stores all the items in the form of boxes full of the item type. Now, the reason we do this is for what is in the name, for when we have a bulk amount of the item type, when you have an ability to fill 1.5 million items or close to that number in term, and you want to be able to store it all relatively compactly and be able to access it all. And what we end up doing is, because we don't always just want to have access to here, we end up using box loaders to also get access to the item form. But that's what a bulk is. Now, a quad bulk just means that there's 4 different bulk silos, and a silo refers to the idea of this little chunk right here where all the items are actually stored. Ooh, there, just fell off there. But a quad bulk just means that you have access to 4 different silos, or in other words, 4 different item types per slice. Now, the items are all sorted using Acacia Chan's box loader, and this keygen over here was designed by Phil Goodinator, and the box loader by Acacia Chan. Again, as in most of my bulk videos, I'm not actually going to break down the box sorter because I have a video on it, and if we add that on top of having to break down all of this, the video would be way too long. But all you have to know is we have the items being sorted through here. It is the item coming through here, gets picked up into the filter, the box gets sucked down, gets stuck in here. Now, if the box is not, or the whole silo isn't overflowing, then it'll just come into this hopper right here and make its way down into this chest. But if it is overflowing, it'll get spat out into this water stream, or if over here, you'll get spat into this water stream. As you can see, the water streams all just join up somewhere where you can fit it into your own storage system as you need. And I think that's all the context you need about this system. So let's just get straight into it. So for this system, once we get the boxes into this chest right here, we actually take a comparator output. And so when this fills up, or when this changes at all, we actually update this observer right here. Now, this observer will power this piston via quasi-connectivity, shifting this entire line down. And when I mean this entire line, I mean this. It'll move it down all the way here. And what ends up happening is we use these 2 observers, the first observer down here to come down here to pulse this piston and this dropper right here. We pulse these 2, the piston to reset the thing, or the connection. So what we end up doing is we shift this down, it'll power this piston, and then shift this back up because that's all we need it for. And then we also pulse this piston up to shove this entire slice up. But because this hasn't unlocked yet, this initial powering to this piston right here doesn't do much. This is where we actually need to start doing signals, and that's where this dropper comes into play. Because we power it, we move this stick down into this dropper right here, and this acts as our reference for whether these top silos, respectively, this set of droppers for this set of silos, or this set of, or singular silo, and this dropper collection for this silo here. And what we do is we pulse it down to move the item into this dropper right here. Once we move this item into the dropper right here, this comparator will no longer be taking an update from the, or taking an output from the dropper, so it'll unpower, unpowering this redstone torch right here, to power this sticky piston right here. Now, this sticky piston will extend all the way upwards, moving all of these up. And if I just quickly go like this, it'll move all of them up like here. And then you will see the fact that it's no longer no blocks, or sorry, observers next to all of these individual signals next to the hoppers, but instead observers. Now, the reason we do this is because with the note blocks right here, we can take a conduction signal from the various conduction signals. So here we have a capacitor into a comparator. A lot of times it's a redstone torch. Here it's a redstone dust from other parts in the system. By allowing conduction, we lock these hoppers on the right here. But when we move them up, the observer will no longer allow the signal to go through. So we don't power these hoppers and we allow the items to flow through this half of the system. Now, on the top side, what ends up happening is this bit gets moved up and this redstone block moves up here. Now, you may think because we change the power of this note block and update this observer, it powers this piston right here and shoves everything back down. But because that piston right there will actually continue to be extended because this state hasn't been restored and is still in the state of unlocked, you could call it, this piston will not be able to push back. What will be able to happen though is this redstone block, when it's moved up to here, if I move it up to here, what it'll do is it'll power this sticky piston right here to extend this line. Now, this line, once it's extended, we will no longer have the signal from this comparator pulling from this capacitor because the glass will be replaced right here. So then we turn off these two hoppers right here, as well as unpowering this note block to retract this piston. And then we use the continuous update of this line right here because this observer watches the update of this hopper right here. And by moving this whole thing up, we'll send quite a few updates. What we can then use that same signal to power this piston to move all of this slice up. And then the redstone blocks will be next to the chests instead of the hoppers, allowing these hoppers to unlock and allowing the full thing to go through. Apart from this hopper right here, which is this other piece of sand actually comes in. With this piece of sand, when it's moved up, this comparator can now take a signal from this capacitor, powering on this redstone line. Now, this redstone line does two things. The first thing is it powers off this redstone torch to turn off this hopper right here, or to turn on, sorry, which will allow us to get our items from all the way up top here and make it all the way down into the box loaders or anywhere in the silo where your current fill level is. However, what also happens is we have this line right here, and I think it's more properly illustrated in this system right here. Now, it is more properly illustrated in the full signal. As you can see, we have a huge comparator subtractor line with the signals that I was just talking about from this comparator coming here. Now, the reason we have this is to have a signal go all the way here into this line, which powers this huge clock right here. And this is our relock and cooldown clock, because whenever one of these redstone dusts gets a signal, it'll subtract from the main line, and because it's a comparator, it'll give a signal strength of 1 in this redstone dust. But because we only have a signal strength of 1 from this capacitor, what ends up happening is we only take 1 away, and it sets the entire line to 0, which allows us to run our little update here to then kickstart the clock. Now, the reason we do this is so we have a little bit of a clock. So we unlock the slice for this amount of time, and then what happens is we relock the entire slice. Now, in this case, we are combining the clock for this set of modules right here, or this set of silos right here, and this set of silos, because they share the same relocking logic that I'll show you in just a second on the actual slice. And so you will have this amount of time before one of these or before the first line gets unlocked, and then it'll run this time because it doesn't send a unique updates each time a slice is unlocked. It sends the first one, and then you have to wait for the entire timer to run out before you can send another to restart the timer. But this shouldn't cause any problems because you have this buffer right here between the actual silo and the box sorter itself, and worst case scenario, it just goes into the overflow, but that should rarely happen. Now, the reason we have a clock is because it is more lag efficient to keep a slice unlocked if we're going to keep sending items towards it. So if we keep sending shulker boxes towards a slice, it's more lag efficient to simply unlock the slice and send all of the items and then relock it once it's all done. Then unlock, send an item, relock, and then unlock again because we're sending another item, and that just ends up wasting a lot of time. And so by just having it relock every set amount of time, which is large enough to get a huge batch through, it ends up being much more lag efficient. So how does the relocking actually work for a system like this? Well, it's super simple. We have this observer line right here, and what ends up happening is we take an observer output from all of these lines right here to pulse this gray concrete. Now with this gray concrete pulsed, what we end up doing is powering these two bottom droppers, which are the droppers where the item will be in if the slice is unlocked or the silo is unlocked. So what ends up happening is if there's an item here, it gets pushed back up, and we'll take this slice for example. It'll get pushed back up, powering this comparator right here, unpowering this line, allowing this black stain gas to retract, because if you remember correctly, we have this entire line pushed up here. So what we end up doing is moving this glass back, and by moving this glass back, we update this observer, which would be all the way up here, and we can see we have the observer up here. We update this observer, which is why we use such a unique combination of blocks for our slider, is so we can actually pass a signal through the slider itself to then do what we were talking about at the beginning, by passing a signal to this note block to run this line, and to now power this piston to push everything back down like so. And then what we do is, because this redstone block is no longer here, this piston retracts, allowing this line to lock or to turn back on, this line to turn back off. So we restore all of this line, restore all of this line, but then we power this line again to then power this note block and push this entire line back down, because again, we only have a pulse coming from this piston, so we don't have to worry about depowering it. And that's how we relock these middle silos right here. Now, when it comes to their box loaders, it gets a little bit interesting because we are working with such limited space, because we have to keep the UI semi-decently, which I think Pyroleft did a tremendous job. I absolutely am a huge fan of this UI. It's super clean, and they're decently within reach. Like, you could reach basically all of them from the indent right here, and you can reach most of the things that you would want from slightly more inwards. Because of the space requirements, we end up having kind of a weird little box loader. Or a box display, sorry, and I believe this top one was designed by Walter. So what ends up happening is we take a readout from the box loader or the box display from this comparator right here, and when this eventually gets emptied out, this comparator will go to 0, updating this observer to pulse this piston right here. Now when we pulse this piston, we move this entire line up, and this allows a couple things to happen. The first of which is we allow power from this comparator to quasi-power this piston right here to extend and break this shulker box right here. Now what ends up happening is, because we break it, we actually use this hopper line right here, because we break it against this dark oak fence gate, so it can fall just perfectly into this hopper line right here, which currently is actually locked, but don't worry about that, we'll get straight into that once we cover the rest of the box replacement bit. But once we break everything, we actually end up sending a signal to this observer, or through this observer, because if you remember, we move all of this up. So this observer will update this redstone repeater right here. Once we power this redstone repeater, we power this note block right here, turning off this redstone torch, but also extending this sticky piston. When we extend this sticky piston right here, what we end up doing is we power or unpower this comparator because it can't read the composter signal. So we unpower this dispenser right here, as well as unpower this hopper right next to it. This allows items from the box or the chest right here to start flowing down and to fill in this hopper and this dispenser right here to get into the position for the box display. And we have some additional logic right here, but we'll talk about that in a second. What also happens is we unpower this repeater right here, which sends 2 updates to this observer and this observer right here. This observer is super simple. It just powers this piston to re-put the slice as it should be. And this observer goes to this rail line, which again, I'll talk about in just a second. But what we end up doing is, since we move this line back down, and because we have enough delay in these 2 repeaters, what ends up happening is this piston, once it gets moved up, if I can move this entire thing, we move it up, and this piston can extend and come back, and then we push everything back down. But then once everything gets moved back down, we can allow this comparator to continue powering this composter, because it's only a short pulse of this repeater for this sticky piston to keep extended, to allow this comparator to repower this redstone wire, to power this dispenser to shoot out the shulker box, and also relock this hopper. Now, this line up here, if I actually go over to the main system, we can find this line right here. And what is this line actually used for? Well, we take this line to send a signal all the way down using some nice little observer updates to run a small clock, but this actually powers the hopper locking line for the box collection. So as you can see right here, we have our box right here that collects both the boxes, or the empty boxes, from this shulker box or this box display and this box display. So what ends up happens, if either one get broke, they get picked up by this hopper when it eventually gets unlocked, and then it can run through the line and go into your storage as however you want it. This means it needs to take a signal from this line up here, like we just said, and it will also take a signal later down the line, which I'll talk about, from this box loader right here. Now, this comparator that I briefly glossed over is actually for the restocking ability of this chest right here. So what ends up happening is, once this chest, if it ever gets empty, either from being pulled out from the box display, or the user just decides to pull out all the boxes, this comparator will go empty and unlock this repeater right here, updating this observer to then power this block right here. Now, by powering this block, we run the same logic of flicking this state back to being unlocked and do the entire unlocking process we talked about before. And this just shows that we don't need to use this line to actually unlock the slice. We can also use just the idea of powering this dropper right here to move the stick down and unpower this comparator right here. Now, one nice little bit of peripherals for these middle silos right here comes from this line right here. Now, this is a super simple line, and essentially what it does is, when it gets updated, it runs this observer line to then power this sticky piston to essentially run the box placing sequence by turning on this sticky piston and allowing this comparator to turn off and then turn back on again, to then power this dispenser again to allow a shulker box to go through. And what we actually do is we use the same signal coming from the locking sequence to run this. As you can see, we have the locking sequence in the middle right here, and we actually take the outputs to go down into all of the individual slices. And this is just a nice little feature that basically allows us to, whenever we relock a slice, to attempt to place the first box in any of these top box displays. And that covers the 2 middle silos pretty easily. So let's just swiftly move on to the 2 extreme silos. And I'd say extreme because they're on the extreme ends of the slice. So just like before, we have the hopper input for the boxes that come from the box sorter. They get just pushed into this chest right here, which this time will actually take an immediate comparator output to go down this line right here. And you'll start to notice a pattern is that we always take a output line to go down to the logic of the system to then unlock the whole slice or the silo. And then we have the relocking logic coming from a input signal from a different part. So what ends up happening is we power this note block right here to extend the sticky piston to send a singular update with this observer. That's a key thing to note, is that we only power this note block for 2 ticks to extend this piston to move this whole thing down, which again will do the same trick we did over there, where we have the piston, we have the observer over there to power the piston to move the whole thing back up. So here we have the observer move down, update this observer, and move the whole slice back up. Now, by doing this, we update this observer right here, and then again, we use the same logic. Sorry, I just realized I had the system in the unlocked state, and that might have caused some confusion. But basically, in the unlocked state, we have the stick in this bottom dropper, as opposed to these middle ones where we have the stick in the top dropper. So what ends up happening is we use the observer update right here to power this block, to power this dropper, to shoot its item back into this top dropper. Now, this is kind of the opposite of what we were doing on the other side, and we're using the positive signal of this comparator to activate the unlocking the signal, as opposed to the negative signal of that comparator right there to unlock the whole slice. So what ends up happening is we use the signal of this comparator to extend this sticky piston. Extending the sticky piston allows this comparator to no longer take a value or take a signal strength from these comparators right here, or this composter right here, sorry, to then run this line right here, which does obviously these two hoppers, and then these two hoppers from this repeater right here. But what also happens is it allows this comparator to read in from this composter to then unpower this redstone torch. And this will also unpower this sticky piston to move down, unpowering this comparator because it no longer has this composter, unlocking these three hoppers. And then we just use more of the same using this redstone torch line to do pretty much the exact same with this comparator and this repeater. And then we just use the individual redstone torch line to get all the way to the top here for these less complex lines. Now, at the same time, when we unpower this comparator, we'll actually turn on this redstone torch to pulse this piston, or to actually keep on this piston to move this entire stack upwards. Now we move this entire stack upwards, and we move this whole thing upwards. And this is where, again, we will see the same redstone subtraction line or comparator subtractor line as we saw on the middle silos. Now, if I actually go through into the system and find it, we can see here we have the same subtraction line, except this time we have separate clocks for each side. This is because for wiring purposes, it would just kind of be slightly annoying to move either one to either side to a general clock. Now at the same time, we have this observer right here watching this hopper right here, but it won't actually use its signal to then power this piston right here, because firstly, it'll happen much later than this signal right here because it has to go through this entire redstone torch line. But because this redstone torch will just stay on, keeping this piston extended, so it won't be able to send its signal. Only when we're relocking the system, when this line gets turned off, we'll be able to then update or turn off this redstone torch, or turn back on, sorry, to then update this observer to then move this entire line down. Speaking of which, let's talk about the relocking system. We talked about the signal to leave the system to say, hey, we should unlock the system. But now let's talk about the relocking. Now the relocking comes from this observer line all the way in the bottom corner, which we can see here coming from this nice little observer line coming from the clock. But if I fall all the way down, we have a huge observer line running all the way to the end. And this also runs into the box loaders, but don't worry about that too much. Basically, by having this huge observer line, we send a pulse to these top droppers, as if you remember, the stick will be in the top dropper if it has, or if the slice is, or the silo is unlocked. And if we power all of these observers in sequence, what will happen is it'll push all the items from the top dropper back down to the bottom dropper, allowing the whole system to run. And I explained basically the most complex bit of it, of the relocking sequence, but essentially everything kind of happens in reverse, apart from the fact that this gets turned off, and then we can actually use the observer update up here to push this slice back down. Time to break down the box displays of these either side silos. So what ends up happening is we have a box with our items in it, as you would expect. And what we end up doing is we take a comparator output from these shulker boxes right here. Now, when the shulker boxes inevitably get emptied, what ends up happening is this comparator right here, it will actually not be able to take a value, or it'll turn off, allowing this sticky piston to retract this observer. Now, because this observer gets moved, we actually update it, powering this piston by quasi-conductivity, because you can see, as we move it up, it can still power it through QC, and that'll send updates down this line right here, which we use for individual updates that I'll talk about later. But what we also do is we send the updates down this line right here. Now, the updates down this line are by the fact that once it gets powered, this glass pane right here will no longer be able to connect to it because it's no longer a full block since it's extending. So we update this observer right here. Now, when we update this observer, it powers this block to update this redstone repeater right here. And when we update this redstone repeater right here, we update this observer to start powering this piston to break the box, because we have no items in these dropper, or this dropper and this dispenser yet. So we can power it to power this piston to break the box and shove it in the same hopper, or the hopper line, to collect the shulker boxes, or the empty shulker boxes. And that's where this signal will come in handy in just a second to actually unlock this line. And we'll talk about the locking of that line in just a second as well with these repeaters right here. But essentially, once we break the box, we actually take this piston to create a quick pulse to update this observer to power this block. And a few ticks later, we'll have the signal from this observer coming from the same observer line that we just talked about to power this block for a couple more ticks to allow all of the systems to run properly. What ends up happening is we will unpower these two torches at the same time, allowing a box to flow through into this hopper, and then into this hopper, and then eventually to this dropper. But what we do is we use the 2 ticks here, and then the 3 ticks of, or 6 game ticks, sorry. So we have the 2 game ticks of this redstone torch and the 6 game ticks of this repeater to perfectly time it with the hopper cooldown timer to relock this hopper right here. To relock this hopper right here to have minimum buffer items to go through all of here. Now, for the box replacement, we just use the same signal for when this repeater eventually dies down to then update this observer right here to then power both of these to then replace the shulker. Now, these wires right here, as we see on the main system, if I just fly over here, we see these wires just all connect to these lines right here, where we update a observer line to run the same clock to then power this line right here. And this is where we actually talk about I can talk about the hopper locking of the empty box lines. So we have just basically 2 repeaters in parallel powering a block and then a block in sequence, so that way we cover all of the individual hoppers. But essentially, when we get a signal here, we turn on a short clock to unlock this hopper line right here to allow any boxes to then go through and go into the respective system. In this case, we just have a dispenser, or a dropper, sorry, to then break, or to dispense the empty boxes to get them to go up here. And if we just follow the line, they end up in the void in this case. But now, just like in the top half, we do have restocking as a feature where we take a comparator from the chest right here. And so if this line were to ever empty and this turns to 0, we'll unpower this redstone repeater right here to then update this note block and update this observer to then power this bottom dropper. Just like in what we did on the other side, we send a signal to then push it, or the stick, into the opposing dropper to then unlock the whole silo to allow all the items to flow down until we get back to good capacity. Now, one last thing to mention right here is this repeater right here and what it's for. Well, if we actually take a peek at the main system right here, we have this line right here. And what we use this repeater for, and it's a bad example in that case, I incorrectly copied this over, but we use this sequence of lines to pulse every single sticky piston right here to attempt to, or to essentially run the sequence to run the box placing sequence. Now, this won't work for slices that already have a box because the box will be powering this comparator and keeping the sticky piston extended, like we can see on that side right here. So no update will happen. But if the slice is empty, every time we relock the extreme sides, we will do our best to send a signal to try and get all the box placements done just automatically. Now, in this case, we just have a super simple sequence coming from this line right here, which gets read out from the hopper locking line. As we can see, we have the relocking line, and it just carries over and goes through some nice little wiring to eventually make its way down to the main system right here to attempt to power every single line. And that is it, ladies and gentlemen. So the UI, I should probably go to the main system for this. But the UI, I think, is absolutely top-notch. It's just so class, and being able to reach everything is just brilliant. There's no visible comparators unless you really go over the edge. Now, unfortunately, you won't be able to cover up these comparators like by doing anything like this, because what will end up happening is first you'll block your vision in the shulker box, but secondly, you'll block the collection of these top shulker boxes going into the hopper line, because it actually uses the comparator to cover the hopper line underneath. But it uses some really nice logic to get all of the main components done, and I am a big fan of just the sheer volume, but it's still relatively compact. While it does use some unique wiring, it gets the job done, and I can imagine it would be quite easy to troubleshoot if something were to go wrong with being unloaded, for example, because the main things you would just check are these states right here to check that all these slices are still locked or unlocked, whether they're supposed to be or not. And I don't think much more apart from that can go wrong, excluding the box sorter. So that is going to be it for today, guys. I really hope you enjoyed. Thank you so much for watching, and I'll catch you in the next one.